Hi friends, welcome to Machine Learning Journey. This is lecture 2 of ML series, and in this video we will understand about data in the machine learning. So basically we will start with what is data, why data matters, and types of data, and furthermore we will discuss few more topics on this. So before I start, uh, basically in the field of machine learning or AI, the most important thing is the data which you collect from your systems so that you can create a model to work on unseen data. So basically in the historical or in the past you collect the data, and this data you feed it to a algorithm or model, and you train it to learn some pattern from this data, and then you create a model which you claim that it can work on unseen data or generic data. So this is all about in the machine learning context. Now we will understand like what exactly data is. So data is a representation of real world objects or real world scenarios or events. For example, if I write 2, 7, 9, 11, 13. So these are the numbers, but this is not data. Okay, this is not data. What data is, if I say this 2, 7, 9, 11 are represents the number of students came in class on different dates. So now this makes sense. The meaningful representation is data, but some random numbers is not data. Now, why this data matters? The first thing is, for example, you open a your YouTube account, and there you can see it recommends you different shorts. This is the series of shorts, let's say, and it represents it suggests you different shorts. In the same as in Insta also, it gives you different reels, right? So how algorithm decides that what kind of reel you want to see in the next? So it decides on the basis of previous signals you gave, or previous likes you made, or previous preference you have set on the accounts. So that all signals goes to algorithm. So algorithm is trained once for complete people on the all the people on the Instagram, but now for a specific person, how it decides what reel needs to be suggested next. So that is decided by your input signals. So that input signals is data. For example, likes, your accounts you follow, or how much time spent on each reel. That kind of data is that kind of inputs is data. Now we will understand in the machine learning. Uh, this data is divided into, in general, not in a machine learning, divided into different categories. So on the basis of representations, the data is divided into two things. One is numerical data. Okay, uh, just a second. I will. Okay, so now we will understand types. One is numerical data, and what is categorical data. Numerical data represents by numbers, for example, age, weight, or number of children in a class, or shoe size. So this kind of data is represented as a number. So it is a numerical data. In the numerical data itself, there are two types. One is continuous data, and one is discrete data. You might have heard about discrete signals and continuous signals somewhere in your schools or in the college. So in the data also there are continuous and discrete. In the continuous data, it is like temperature, which takes say let's say 37.2 degrees Celsius. So it can be more. So mostly it is a decimal data, or blood pressure. or so this kind of things which represent as a decimal. Most of the time it's a continuous data. In discrete data, basically it is a fixed numbers. So for example, if I say how many number of children in the class, you will say 2, 5, 3, but you won't say 2.517. You won't talk like that, right? So it is a discrete, it's a fixed. So even a shoe size also, your shoe size can be 10 or 12 or 20. It can't be 10.5. So it's a fixed number. So that is a discrete. So I will recap it. Types of data: numerical data represented by numbers, categorical data we will understand. In numerical, there are two types: continuous and discrete. Continuous are like temperature or blood pressure, which represents in decimal. Discrete are fixed numbers, for example, number of children in a class or shoe size. Okay, in the category itself, there are two types. One is ordinal and one is nominal. In the ordinal data, it is like hierarchical data. Okay, it is represented by some hierarchy, or uh, let's say there is some uh, range, let's say, like that kind of data is represented in the ordinal data. Let's say I say what is a temperature right now. So if you say low or medium or high, so it comes with some hierarchy where low comes first, mid, then high. So this is ordinal data. Whereas in the numerical data or nominal data, sorry, it is like represented by name. For example, color. What is the color of your shirt? So you will say red. So you will say green. So here it is not like green come first, red comes after that. It is nothing like that. It's just represented by name. For example, gender. In the gender, you say either male, female. So it has no hierarchy. It is just represented by some category. Eventually, it is a category data, but inside category also, it is just represented by name. In the ordinal data, it is represented in some hierarchy. Okay. For example, when you visit some, okay, you visit, if you visit any websites, or if you do some, or you buy some products, there they ask about ratings. So the rating is also a hierarchical, categorical ordinal data, which also represents a just a second. Rating also represents some hierarchy. Okay, 1 star rating. So they ask you to fill 1 star, 2 star, 3 star. So one comes first, five comes later. So this is some hierarchy. So it is ordinal data. Nominal data is represented by names, gender or colors, or some blood type also. Blood pressure is continuous data, which is in numerical data, but blood type where A, blood group A, B positive, B, A, B, something like that. So these are fixed category. There is no hierarchy. Okay. So these are types of data. Now we will understand the types of data on the basis of structure. Okay. On the basis of structure, there are two types of data. One is structured data. One is unstructured data. Structured data and unstructured data. So most of the data is from unstructured in the world, about 70 to 80%. What it is, I will explain. Why it is, you will only figure out. So structured data is like represented in the form of tables, or in the SQL database, if you have heard. It's like representations with some rows and columns. Okay, so for example, if I say you are planning to uh, create one data set of a number of children came into the class and their marks, number of students, their roll number, let's say, marks, which class they are studying, all these representations are there. And then so let's say if you figure out, also here you say name, so you write the name, you write the marks, you write the roll number, you say which class you are studying, again name. So each row is a representation of one entity in your data, and this complete set is one structured data, which is because it is structured in a proper format of row and columns, which each column represents some entity and each row is a one complete object of that data or representations. Correct. Now in the unstructured data, it is a raw data, completely lacks defined conceptual structure of formatting of model. For example, it is like uh, audio, videos, images. There is no proper formatting of this data. There are just uh, representation of something by some numbers, or in the image we can say pixels, in the videos we can say frames of images, so like that. So there is no structure in this. If I say 10 GB data, it means 10 GB images are there. There is no structure, which image comes first, which image comes last, or what each image represents. There is nothing like that. So it is unstructured data. In the field of machine learning, to train any model, everything needs to be converted to numbers. So every data you have, you need to convert into numbers. Okay. So if it is a categorical data, you have gender, let's say male and female. So if you represent male by 0 and female by 1, like that you can do. Or if you have some images, set of images, let's say 200 images you have, and then 100 images are cat and 100 images of dog, then you have to say that cat images I am representing by 0 and it is by 1. So now everything needs to be represented in number, then only you can train the models, because human, we see a cat image, we process it, but computer see numbers. So in the end, whatever representation of the real world scenario you can convert into data, and then data can you can convert into numbers, then you can train the model. So now there comes a quality of data. Quality of data means, like, a good data equals to a good model. Of course, the complexity of algorithm also takes place, but the first thing is the good data. If you have good data, you can create a good model. But with a bad data, it always gives a bad model, no matters how good your model or complex algorithm is. Okay. So what are the things needs to be considered in the bad data? What is definition of bad data is, like, if you have some data and the values are missing. So if you have some tabular data and some values are missing, then it is called a bad data. When there are duplicate rows, again and against the same rows appears multiple times, then the data, that when you train the model, it is specifically trained on the same data again and again. So that is also there in a bad data, missing values, bad data. And on wrong labeling. For example, when you classify, when you have set of images and you labeled each image either cat or dog, then image one, let's say it is a cat, but you labeled as a dog. So while learning, it will misclassify and model will be confused. So that is a bad data, which is a wrong labels. Labels means ground truth. Long ground truth is also a part of bad data. So these are the few things which you needs to consider. While training, eventually you will learn what are the issues with data when you backtrack the models when it fails at some scenarios. So this is all about the data. Everything goes to the numbers, you have understood. Now, like, good data creates a good model. Always remember, if bad data goes in, bad model comes out. That is simple, is like garbage in, garbage out. Okay, bad data you have, then bad learning will be done by the model, bad model will be created, and bad predictions will be there. So overall, this is the overall idea of a data. So in this video, just you need to represent that, you need to remember that data is a representation of real world scenarios, objects or scenes, and that if that data can be converted into the numbers or numerical representation, then you can train the model. That is simple. And these things you can remember. it's not memorizing, but you just remember the types of data as numerical and categorical data. Numerical data are continuous or discrete. Numerical means numbers. Continuous, either it can be continuous, either it can be discrete. Categorical data, ordinal or nominal. Ordinal is like hierarchical data, something like ratings or low, mid, high. Nominal data is represented by just names like color or gender or blood type. These are, which is represented by the names. In the structured data and unstructured, on the basis of structure, there are two types, structured and unstructured data. Structured data represented in the tabular format, where you have some column names, and then for each row there is a one entity, and the complete table is a one structured data of some representation. For example, it can be a transaction also. In the transaction, you will say customer ID, amount, time. So likewise, you fill the rows. So that is a structured data. Unstructured data is like audio, images, videos, whatever the reels, even what we have discussed, that is stored in the DB, that are all on unstructured data. Why I said 7 to 80%? Because most of the data revolves around it is, and most of the data consumption is done on this unstructured data. ML models, in the context of ML models, like every data you have to convert it into some numerical representation. Then you can teach a computer or a system or algorithm that this number represent this thing in the real world, and then while making the prediction, it will predict that particular number, and then you will map it to your real world, whatever representation you gave before training. So this is about ML context. Now, quality of data. So, good data, good model, bad data, bad model. Complexity of algorithm comes later. The first thing is you need to have a good data. Bad data definitions are same like duplicates or wrong labels or missing values. This can be a definition of bad data. Okay. So overall, we understood about data in this lecture. No need to memorize anything. We will train some model in the future lecture, and you will understand what is the importance of data. Just for an overview, you can like have one idea. Thank you for watching. Thanks a lot.